We've got the normal distribution, and here is our question. So the amount of orange juice, X millimeters, in a carton produced by Mass Juices Limited is modeled by the following distribution. So it's normally distributed, and you've got to remember what the 500 stands for and what the 49 stands for. Okay, so remember, the 500 is your mean, and 49 is your variance or your standard deviation squared. So here's your questions. You've got a couple of things to look for, a few probabilities. Have a go. We'll catch up in a couple of seconds to go through the answers. Okay, it is solution time. So let's get cracking. The most important thing with our normal distributions is going to be the distribution itself. We've got to get a few things right from the start. So the 500, what does that represent? It represents our mean. Remember, that's bang in the middle of our distribution. And 49 there is going to be our variance. So what I'm going to do is write down our standard deviation, because that's the more important thing here, is going to be 7. Now, what do we need to look for? We need to look for the probability of a carton of juice having more than 503 milliliters inside of it. What we should do is make a sketch. A sketch is so important to solving all of these problems. So I'm going to draw our bell-shaped curve there. That's for our normal distribution. The mean right in the middle, which is 500 milliliters. And what we're looking for is something that's greater than 503 milliliters. So there's 503. And what we need to look for, therefore, is the area to the right of that there. So we're looking for this area underneath here. How are we going to find it? Well, we can use our calculator. So how do we do that? Hit menu. We're looking at distribution. So distribution, there we go. And we're looking for the normal CD, option number 2. There we go. So this will open up. We've got lower, we've got upper, and I think we've got standard deviation and mean. So we can fill in all of those things. Now, the lower value we're filling in here is 503 because that's where our probability is going to start from, right? That's our lower there. Now, technically, this is going to go on and on and on and on forever because this here doesn't really ever touch the axis. So what we need to do for our upper is put a really large number in. I'm just going to say that's going to be 10,000. Next, our standard deviation, which we said is 7. So I'm going to put 7 in there, equals. And then our mean finally, which is 500. So let's put 500 into there. Okay, lovely, hit equals one more time. And there we go, we've got our probability. So the probability of X being larger than 503 is going to be 0.334 to 3 significant figures. There we go. Now, part B. Same thing, let's make a sketch again. So here's our sketch. We'll have the bell-shaped curve. And then in the middle, we've got 500 milliliters. There we go. And that's mu. But now what are we looking for? Now we're looking for an orange juice carton here having less than 495 milliliters. So 495 is obviously on the left-hand side of 500, right? So let's pop that maybe here. We'll go 495 mils. And this time, what are we looking for? Well, less than. So we're looking for the area to the left of that there. So we need this area. So again, we can still use our normal CD, but this time our lower is going to be, well, 0, because that's surely the smallest amount of liquid that could be in this orange juice carton. And the upper is going to be 495. So 495 there is our upper. Our standard deviation is still the same, hasn't changed, and our mean is still the same as well. So we just hit that all in, and altogether that comes out as, we'll go with 0.238 to 3 significant figures. Okay, done. Now for the last part, part C. We've got a sample of 4 cartons are taken, and we need to find the probability that at least 2 contain more than 503 milliliters. Now what you will notice is we've kind of already worked out the probability of one of these cartons having more than 503 milliliters. We actually worked it out there in part A. And the next thing we'll need to realize is, to solve this problem, we actually need to write a binomial distribution. So here's what we're going to go with. We're going to say that this variable now, we'll call it y, can be binomially distributed, where there are 4 cartons, and the probability of containing more than 503 mils in there is going to be 0.334. Awesome. And now what are we looking for? We're looking for the probability that at least 2 contain more than 503. So we're looking for the probability that X is greater than or equal to 2. So remember, how do we find this? This is very common, right? We've got binomial mixed in with a bit of normal distribution. And so what we'll need to do is we'll head back to our menu. We need our distribution. This time we're looking for our binomial distribution. So we're going to have to scroll downwards there. Binomial CD is what we're looking for. And we'll go for variable. Now, what do we need to put in as x? Because what we're looking for here is x is greater than or equal to 2. Now, the possible outcomes are, well, no cartons could have more than 503 mils. One carton could have more than 503 mils. 2 could, 3 could, or 4 could, because there was 4 cartons here. Another probability we're interested in is where x is greater than or equal to 2. So we want this region. And how are we going to get that? We're going to need to do 1 minus whatever this is over here. So to work that out, we need to do 1 minus the probability that x is less than or equal to 1. So in my calculator, what I'm going to put in is x as 1. Because remember, binomial CD gives you probability up to and including a certain value. N is going to be 4, and the probability there is 0. We'll go 334. There we go. And so what we need to do is 1 subtract 0. We'll go 591. And then what we can do is we'll store that as A back here. And then we do 1 minus A. And there's our value. There it is. So we'll have 0.409 is what we'll go with. And there's our answer. Fantastic. And so there it is. Hopefully you have got that question correct. If not, I now hope you know how to solve it. So with normal distributions, really important you understand what your distribution actually represents and how to use this over here, right? That's how you're going to solve all of those problems. Okay, more normal distributions coming. Stay tuned and I'll catch you in another video real soon.